All right, we are back at the podcast. Yeah. So yeah, I'm back with a dear friend, Mr. Netshifheffe, and welcome back.
Yeah, thanks. It's good to be back. Hey, it's good to be back on Stake podcast. It's been a minute, but we always at it, man. So yeah, thanks for having me.
Awesome. I think where I wanted to start, I like the presentation that you did the other day at church, where we were talking about how you guys work with milk.
Milk.
Yes.
Oh, imagine having to tell a 5-year-old, "What does daddy do?" Hey, I work with milk. Hey,
Yeah.
like are you milking cows or something?
Exactly, and I think I liked how you explain the process of the milk that we get in our homes, but there's a huge process that happens before that happens, and I
Yeah.
think you're an expert on that. So I just wanted to just explain that if you can, and get into the details, like the super details, and you can just dumb it down for us who don't understand the mechanical that much.
Okay. Well, let's see. Where do we start? So
Okay,
I'll
sorry. Please just introduce yourself because
Oh.
I'm assuming that people already know you. But I
Okay.
think maybe just to make it easier, just introduce yourself and then maybe you can just get to that question that I asked you.
Okay, awesome. My name is Bonie, Netshifhefhe, I think, and I'm a project engineer by title, but normally do processes of engineering. I do codes, I do technical reviews. I work for a company called Tetra Pak. That's a company that does with food and beverage. Basically, that's why you're saying I do milk. And yeah, I'm married with a beautiful wife, and I go to Redemption Center International. I'm born again. I love Jesus, and yeah, that's basically who I am. You can get me on my DM, Instagram. Okay, guys. Okay, let's not do that. Okay, yeah. So, yeah, let's get to it, my friend. So yeah, like I said, thank you so much. This is my friend. So most of the time we'll be just joking around
Sure.
while enjoying life. So yeah, basically, what I do, it's more of let's talk on the dairy side of life, right? So most of the time when we speak about dairy, you think of milk. Well, that's basically what dairy is. And from milk, there's a lot of products which we call the byproducts that can be done from milk, like your cheese, fava milk, marcy, and everything. So those are cheesecakes, milk tarts. Those are all byproducts, the custards. Those are all byproducts of milk. So I think milk is it's quite a huge sector in the country or in the university in large. So where do we start? We start if you come from the rurals. I think
Start from the farm, I guess.
from the farm. Yeah, basically start from the rurals and the farms. Normally, you would see yourself milking cows if you have ever done it. I doubt the 2000s might know it.
I haven't even done it.
You haven't even done it. Oh wow. Okay, cool. Well, you missed out a lot.
Yeah.
But basically, you go, you milk a cow, and then the traditional way that you used to do it, you milk a cow, and then you would depending on what you want, back in the days, you would put the milk in tub. I'm not sure if it's a tub. What do you call that thing? Like a
Bucket.
container bucket. Yes,
Yes,
a
bucket,
bucket. Then you put it there. Then you would have to use it immediately if you don't put it in the fridge, if you don't refrigerate it. Then after some time, even if you put it in the fridge, but after some time you notice that you would find the cream would go up, and on the bottom you will get water.
Water, okay,
Yeah,
sure,
so
sure.
basically then you have the cream, then you've got your whey. That's what we call the whey.
Okay.
So basically that's what you would have, and then in the older days they would normally want to do, like when you bake scones and everything, you use that whey to bake scones because they're quite good.
Okay.
But you'll notice that milk would not last as much as you would want it to. So that's where the processes came in to say, how do we preserve milk for a longer duration of time without making it lose its flavor and taste? That's where the whole technology started coming in. So basically, when you go, you milk a cow, everything is being done automated this day. So you've got like a farmer who has like probably like 5,000 to 10,000 cows. And they're farming, depending on how big they are, they can be farming close to like 30,000 liters of milk a day, or even more, depending on what
30,000 liters.
liters of milk a day. Yeah, a day.
a lot, yeah.
So that's a lot, yeah, definitely. Because I'm not sure of numbers. Maybe we need a fact checker.
So we need a fact check.
Yeah, so probably like, I don't know how many liters can one cow maybe do. I don't know, but yeah, I know big farmers they can do like 30,000 above a liter a day. So then what you'd want to do, majority of the things, is that on your milk you've got something or bacteria which are called pathogens. So those are your unwanted bacteria. They're the ones that grow, and when they grow, they're the one that makes the separation of milk and whey.
Oh, in whey,
So
okay,
they
sure.
make it separate, and you don't want that to happen.
Okay.
So those pathogens or those bacteria, they thrive in room temperature and in hot temperature. So they basically grow quick in those temperatures. So what you want to do, you want to make sure that you treat them before they can grow. So every time they start milking, they reduce the temperature of the milk to 4 degrees. That's the ideal temperature you want it to be.
Okay.
So they milk it immediately. When it comes from the cows, it goes through a heat exchanger, which just basically drops the temperature of the milk from ambient, whether it can be like probably 25, 30, because it's a bit warm because it's coming from the cow, and it drops it to 4 degrees. Then from 4 degrees, they put it in the tankers. So tankers, normally if you drive on the road, you see those big tanks with vessels. Yeah. So those tankers, most of them would have cooling jackets.
So speaking of my
Most of them would have like cooling jackets, but cooling jackets are basically just to make sure that it doesn't get hot. Yeah. Then they take it to the dairy. That's where my work starts. So basically, you take it to the dairy. Then when you get to the dairy, they do their checks to make sure.
So maybe I just want to go back. So which means they're milking the cow, they're taking it. So the process of preserving this milk, it's already started when they're milking.
Correct.
So they're taking it down so that it gets to the 4 degree that you mentioned.
Correct. Yes.
From there, then they're taking it to the tankers now.
To the tankers, yes.
Okay,
So basically, they would take it in, then they'll put it into your farmers. Will put it into the what we call silos, which is just basically big tanks.
Okay.
So they put it into the silos. Then from there, they would distribute to tankers depending on how many, like I said, liters they're doing per day and how many dairies they are giving out. So you can find that one farmer is supplying 4 dairies.
Okay.
So maybe they've got a contract to say, okay, cool, every day we'll come and take 30. Every day we'll come and take 50 or 60. So basically that's what they would do, or less, depending on what they have.
Sure.
Yeah. So then from there you put it in. Then when it goes to your dairy side, that's where now I start. So your dairies are your big dairy guys, like your Clover, your Parmalat, your Woodlands, your Pioneer Foods, your Aspens. So you've got the big ones. So you've got your Fair Cape.
Fair Cape, yes.
Yeah, you've got your Fair Cape. So you've got all those big farmers or big dairies that we know around South Africa, right? So now it goes there. So when it gets there, that's when we start in my company what we call the processing side. So processing side is just basically meaning the processing of the milk.
The milk, yeah.
In basic terms. So now what we do, we make sure that, the customer makes sure that the milk is of high quality or as agreed to say we want to get, because you don't want to get fake or bad quality of milk, because that already makes sure that your product is going to be bad at the end of the day.
Sure.
So whatever comes in is what comes out. So we can't make the product better than what it is.
Okay, sure.
Unless you add sugar.
Makes sense, yeah.
Unless you add sugar. But in milk, you don't want to add sugar anyways.
Yeah.
Otherwise, unless you want to have flavored milk, then you add sugar, which we can talk about later. So now that's basically what happens. So now the guys will check. That's when your microbiological guys, I'm not sure if you've heard one of the guys, maybe they can tell us.
I actually had Mr.
Mahlombe, yes.
Yes.
But he works, people like him.
Yes, because they test.
But he works more in testing of the things,
vaccines, yes.
So someone like the lady we were talking to the other day, I forgot,
We must bring her to the podcast.
We must bring her to the podcast. Then she can tell you more about the testing, how they check for certain bacteria. One thing that I make sure, which we know they check for, is water. because sometimes if farmers does not reach their goal,
All the
they can basically add water into the milk. So now it reduces the quality of the milk,
Sure,
right? So they
sure.
always check the water quantity in the milk and everything. So it's quite an easy process and fun to see. There's a guy that goes the long stick in the big tankers. He first mix everything, then he just takes a random, just takes a random cup and then he puts it in a nice measuring thing. What they call those things? Yeah, cup. It's a measuring cup. So then he takes it to the lab. Then they bring back the results. If they give a green thumbs up, then we pump it out. So this is where the processing starts. That's where what I used to do in my first 2.5 years in my company.
Sure.
I was doing the processing side. Now I'm doing the packaging side.
Okay.
So now that's when you start now having to number one.
So you're going to explain the processing side, right?
Now I'm explaining the processing side, right?
Okay.
So
So
now
I think maybe I just want to understand, because I feel like this podcast can also be helpful for someone who wants to get into this business. So you guys are not responsible for the truck that's bringing
correct.
the milk to the plant, right? You just check if the quality of the milk is good.
We don't do
then
that.
So is the microbiologist, like you said?
That's okay. That's a good question. So basically, what happens is that's where you need to know if you have a business, what are your specialties? Because you don't want to go overboard and make yourself do things that you're not specializing in, right?
Okay.
So my company deals with processing equipments. So I work with processing equipments, not to check the quality of the products. No, I do with processing equipments. When I'm maybe I'll tell you when I'm going. But when I'm done with the processing equipment, the customer customer, which we call the customer or the dairy guys, are the one who are responsible to check the quality of their product. So when they come to tell us, they'll tell us, okay, I want to get this quality of product at the end. I will bet you, okay, my machine can do it, but the customer still has to check that quality themselves.
Okay, yes.
So I don't check qualities, right? I don't check qualities.
So which means when you guys get the product or the raw material,
yes,
you get it once it's already checked, everything is
customer does everything for that. So the only thing that I would tell them, if we get an issue, which is something we're gonna talk about when we get to the packaging side.
Yes.
If we get an issue, that's when we start doing the fault finding. That's when we bring our quality guys. We have a quality team.
Sure.
When they come in now, they are more like your microbiological guys. They're quite special in that. Then they'll be telling you, okay, cool. Let's see where the fault is.
Where the pressure was.
Where is maybe there's an opening, or maybe there's a bad weld, or the pipe is too long. So now because of this, you're gaining less what, all those funny stuff. So that's when they come in.
Okay.
So now when they come in, they come in with more knowledge of
quality check.
Quality
check on the machine.
on the machine.
Yes. Okay.
Which they also have to have an understanding of the product.
Sure.
Also, you get me. So now they are more on the machine, but they also know the product. So basically, if you're processing a milk that has a cream content or fat content, we call it, of more than 5, and a milk that has fat content of more than 4, they react differently in the machine.
Is that percentage? Or?
Percentage, yes, percentage of fat. So basically, when you milk your cow, it comes out in a percentage of, depending on the quality of the cow. This is where now maybe the farmers, what they're feeding the cows and everything.
Okay.
It normally will come, say 4. That's good. That's very good. Bad, maybe 3%.
Okay.
Of fat. And then when you've got like your Jersey cows, they call them the Jersey cows. Those are good quality cows. They can give you like 6.
Oh, so does that mean that
of fat?
So which means more fat, it means more quality.
More fat, in a way, means more quality. But when you do your full cream, there's a spec, so we cut it short. So it means now you've got more fat to do more byproducts, like your margarine.
I see. Yes.
Your cream, your whipping cream, and everything. So now so if you're a dairy that does those things, that's good for you.
Very happy. Yeah,
yes.
sure. Makes
so
sense.
now you've got more excess fat to do other stuff.
Makes nice. Okay.
Yes.
So going back to the processing, I think the question was, okay, do you guys work on?
No.
Yes. So just continue. Maybe
So
from
yeah.
there.
So basically we don't. The customer has to do all the checks and everything for the milk. So now what happens is we make sure the tankers normally come with a pump. They normally drive with a pump. When now they could just connect it inside their factory, then they'll pump the milk into the silos, the big silos.
Sure.
So, because maybe dairy is running daily, whatever. So sometimes you get equipment failure, which you can't run already.
Yeah.
So you are allowed to keep milk in a silo for 22 days maximum. So if you keep, because those silos, even though they've got cooling jackets, but if you keep it for more than 2 days, your product is bad quality. Have to throw it in drain. And those silos are probably like 50 to 100,000 liters per tank. So if you really lose it, then that's bad. They don't want to do that. So you want to at least do the first process to preserve it quicker than just keep it in that case. So that's what normally happens.
I just want to comment a bit there for someone who's listening that I think this is what we talked about on our previous podcast, saying that sometimes they actually don't tell us how important it is not to mess up on a project. Like let's say if you, for whatever reasons, you are supposed to check the level of how much the silos, like how many days, and you mess up, that means the whole company now is going to lose lots of millions of rands just by you leaving or messing up the product.
That's very important. That's why in engineering we're known for paying close attention to detail. Okay. Very important. You can't mess that up, right? You can, but that's going to cost you a lot of money. Sure. And depending on which company you work for, you can get fired.
True.
You can get fired, literally.
Yeah.
So that really plays a huge role, right? That's when you would want to go extra mile most of the time. It might not be your responsibility to check the milk and make sure whatever. You just want to say, okay, am I getting milk in this machine? Yes, I'm getting the milk. But if you're getting spoiled milk, then it can seem like your machine is not working.
Sure.
Right? And the guys who are working, because normally we work with customers who have their own operators who are working and everything, right?
Yes.
I remember this time I was in KZN. These guys, so basically you need to, when you wash, because you have to wash the tanks, right?
Okay.
You need to wash them. So you use swing bands. So swing bands, do you know a swing band? So a swing band is like basically a pipe that selects different tanks.
Okay.
So from a source, then you can select, okay, I want to use this tank, I want to use that tank. So instead of using an automated system, it's a manual system. So that's what they call it, swing band.
I see.
So it's more manual, so cheaper. The guys are willing for it. So basically you do that.
Get an operator
so you
for
do
that,
that most of the time if the labor cost in the country is less. If you go to Malawi, those guys most of the time, they do everything manually because the labor cost is very less.
So you rather not have...
yes, but if you go to the US, the labor cost is very high. So they all go for the automated systems.
Okay.
Yes, because then it's cheaper. They get
so
to save.
They want AI.
Yes, they want. No wonder why they want AI, because guys, they are very expensive, right?
Sure.
So now this guy, they had like, and that's cream. So now they were actually bringing cream because they were not doing cream in that factory. So they used to bring cream from the tankers.
Sure.
I think they had like 60 or 70,000 liters of cream in a tank. So this guy, instead of selecting to wash a tank for the milk on the previous shift, he selected the tank of the milk, the cream. So now basically all the chemicals moved from the CIP station, which is just the cleaning station, and went everything inside the cream. They had to dump the whole 70,000 liters of cream. Like literally, I went to site, I'm just seeing cream on the floor going down. Yo, that guy was angry. They all was angry. But anyways, that's just something that it happens. So that's why we need to. I think we need to really be
I guess
pay attention to details.
That's the reason why maybe someone would rather go for a automated system than having to have a human, because human being has that possibility
of
human errors.
And an automated system, if there's something is not correct, it just goes to fault.
Just a coding, sure.
You just go to fault.
Exactly.
Then it stops. Then you need to go there and double check. So that's the good thing about it. But it comes at a cost at the end of the day.
Exactly.
Because, if you show you the cost
maintenance and all the stuff.
It's quite high. Anyways, so what do we say? So
we're just getting into the process now.
The process. Okay, cool. So now we bring in the milk, boom,
into the silos.
We pump it. Yeah, it's in the silos already.
Yes.
So we pump it out of the silos. When we pump it into the silos, before
I think the listeners, I just want them to understand. I'm also as curious, so that's why I'm asking so many questions. I just want to. So the problem is that the listeners they will be saying that this guy is just interrupting you.
That's good. We need questions. That's why we're here.
So I want to understand for myself. Just a quick question on the silos. Do you have to wait for the milk inside the silo to finish, or you can actually mix different products? Like let's say if there's already a product inside, and I'm just coming to refill. Can I refill, or you have to wait for that batch to finish because maybe the batches are not the same? Is that what you do?
So good standards will tell you that you don't want to mix milk.
Which makes sense, yeah.
Yes, you don't want to mix milk. So basically, you need to first fill up whatever silo you're filling up with one truck, or they call it the day's milk.
Okay.
So, because normally you would have like a day truck, whatever time you come, or shift milk. So that whatever shift has, it stays there. Then you whatever comes after, you need to put it in a different tank.
Different tank. Okay,
Yes.
makes
so
sense.
that also reduces risk.
No,
If there
because I
is
wanted to know
anything,
because maybe that might be another way of saving cost or whatever. I don't know, but
So no, it can be, but it might have a huge
risky.
risk
Yes,
itself.
that's true.
Because now you're mixing. I'm gonna give you an example. Like I told you, you need to put milk for a certain number of time in your number of hours in the tank. So now if you mix hey,
fresh
slow.
one.
If you mix two milk with one only left to 3 hours and one that still has a
I
good
think-
80 hours, you're contaminating the other one.
that's true. I think what I'm thinking is like it's a classic Bible verse where it talks about don't mix new wine skin in the
yes.
old wine skin.
Yes, don't use new wine in an old wine
Old
skin.
skin, yes.
Yes,
Okay.
that can
Sorry
become a good
for that. You can just continue.
yeah, no, definitely. So now we pump it in. We use what we call we now make sure, because sometimes some of the tankers don't have cooling jackets, so the milk can come in a bit higher degrees, probably 5 or 6, 7, depending on the temperature and where you are in the province or whatever.
Sure.
So when it comes in, we drop the temperature again to 4 degrees or 3, depending. You don't want to go too low because you're going to freeze the milk. So you go to like 3, and then from there we put what we call a deaerator to remove all the air. You know that air is the one that probably has the most of the bacteria. So anything with air, we don't want air in our systems. Very bad for the process.
So
we
the
don't
air-
need- we don't like air. Air is it's enemy number 1. Don't want air at
Sure,
all. So
sure.
so use the deaerator. Just remove all the air we can. You can't remove 100%, but you remove majority of it. So then you put it in the silos. Then they sit there. Then once they're done, then from there it depends on what the customer is doing. So now let's go to the more traditional one, which is your normal UHT milk, which is the one that most people buy in cartons or in a 6-pack. In
UHT,
your
which means?
UHT. So UHT means ultra high temperature.
Okay.
Ultra high temperature treated thing. Yeah. So now from the UHT, you go for the first process is what we call This depends. So now in our company, okay, I don't want to sell stuff for our company, but we've got different technologies that can process the milk in different times, right? So if you go, you put it in something we call a pasteurizer. So basically a pasteurizer, you're pasteurizing milk, you are heating milk to 93 degrees and holding it for 15 seconds.
Okay.
So in that, what you do, I don't want to be too technical also again. You are basically killing the pathogens which are crucial to grow inside the milk if it stays for long. You get me? Like I told you, for 24 hours.
Yes.
So basically killing it. But this killing it, it's very technical. It doesn't mean that they're dead. So I like to say whenever I'm explaining someone, you put them to sleep.
Okay.
So these guys, they can sleep for long.
Okay.
But they wake up, but they can sleep for long, right?
Okay, sure,
So now you are putting them to sleep. So when you pasteurize, depending on so now there's many varieties of pasteurization. You can put it for maybe some people heat it for like 103 degrees and hold it for 5 seconds. So basically you need to change. But the standard one which we use is you need to heat it to 93 and hold it for 15 seconds. So now when you heat it to 93, you hold it for 15 seconds, then you drop it down again after that rapidly. So you drop it down to like depending on where you're going to put it. So if you're going to put it back into the tank, then you can drop it down to like your 4 again, so that it's always cool.
Okay.
So now this when you do this pasteurization, you are making these pathogens or these bacteria in the milk to sleep for a certain period of time. So normally it can sleep for like a month,
Okay.
but you know that we always have to be sure as engineers and make sure that the consumer is safe. So we always tell you 2 weeks.
Okay.
2
Okay.
weeks. So
Makes sense. Yeah.
any pasteurized milk can only stay in the shelf for 2 weeks.
2 weeks. Yeah.
and it stays in the shelf for 2 weeks. It has to be refrigerated all the time. You can't keep it at ambient temperature.
I don't wanna seem as if I'm getting my head of myself. Is that now the sachet milk compared to the one in the different box package?
Yes. So basically, that milk, okay, so after pasteurization, like I said, they normally would put it, depending on what they want to do. As I said, we go in the UHT route, right?
Okay.
But let's just divert a bit. So now, if you go to your ShopRite, you normally hold, there's this milk for like a 2 liter milk.
2 liter one,
that you
yes.
normally hold.
Yes.
Or the sachet you're speaking about, the 1 liter sachets. Yeah.
Yes,
So
yes.
those are pasteurized milk. So they put
Okay.
them in a tank. After putting them in the tank, now they do the packaging. That I don't do because we are environmental friendly. So we don't do plastics and all
Come
that.
on. Sure.
We don't use plastics and tins. We're
Yeah.
environmental friendly. Save the environment. Very important.
Let's throw those shots.
Very important.
Yes.
Save the environment.
Save-
So
Save the earth,
yeah, save the earth. So basically, from if they're doing pasteurized milk, they take it and now they go put it in their sachets, whatever.
Sure.
I don't know that process because I don't work in that sector. But I know I've seen their machines because when I'm on site, I see. So basically, that's when you see your filmatic. I know those guys are the ones who work on it. The growth, they work on those machines. We don't work on them.
Okay.
So now they go and package it. So it has to be on 4 degrees, and when you put it, you need to put it in the freezer. The freezer, which mostly recommended, has to be less than 7 degrees every time.
Okay, sure.
So normally, your normal freezer at home, people don't know. Normally, if it doesn't have a setting, it would run at like 4 degrees to 3, somewhere there. Yeah, most of the time.
Okay.
Yeah, that's what your normal freezer would be. Unless you can adjust it to higher, then that's fine.
Sure.
Nowadays, freezers are more smarter and everything to save energy at the end of the day. Because the more freezing it gets, the more energy it draws.
It draws, yeah.
So yeah, anyways. So now, that milk which is pasteurized, it's good.
Okay.
People would say, I'm not sure, maybe the guys can go and make it a test. Go buy a UHT milk and buy a pasteurized milk and tell me if you can taste the difference.
Okay.
People would say pasteurized milk still has the good flavor, while the UHT milk has like a burnt flavor kind of a thing.
Okay.
I'm not sure if you have
the thing
ever.
is,
I'm not sure if you have ever tasted it.
To be honest with you, I don't think I'm that aware.
You're not that aware. Yeah.
Yes.
Yeah,
I
most
think I'm
people-
not that aware.
so-
but now that you say it, I think I might try to.
Please go try
tell
it
the
and,
difference,
and see if you can feel the difference. Most people when I went to the UK, they actually prefer pasteurized milk than UHT milk.
Okay.
So the market is actually higher on the pasteurized than on the UHT.
Sure.
But if you come to Africa, UHT is way more higher than the pasteurized because they are, but that also depends. So they are more big on flavor and everything, but also accessibility. They are more rich than where we are.
And probably they have fridges
and they've
to
got
keep
fridges.
them,
With us, you want to keep it, you can't just buy it. You can just easily every day go run to whatever. It takes time, you get me? So that's why most of the time, what we do, the companies that sells pasteurized milk, they have to be locally.
Okay.
Because if I have to take my pasteurized milk to Limpopo, by the time it gets there, it's getting expired. So it's a waste.
yeah.
So now Limpopo, that's why you notice that Limpopo dairies, okay, I'm supposed to say names, but Limpopo dairies,
Sure.
Limpopo dairies would not be bringing anything this side.
Decide, yeah, sure.
Yeah, because then you have Clover. They've got a site here. They've got a site in Joburg. They've got
Almost
a site
everywhere, yeah, sure.
Yeah, because now they have to serve that market.
Sure.
But yeah, anyways, that's basically your pasteurized milk. That's the pasteurization process. Very interesting and good. Then you get to like, okay, cool. I wanna get my milk where it can last me for like 9 months, 10 months. Okay, what do I do then? Cool. Now we go to the process which you call UHT, ultra high temperature. So basically here you go from a pasteurizer. Okay, I didn't get into details of how the pasteurizer work, but let's just leave it as that. It's going to be too technical, right?
Sure.
Then from there you move from a pasteurizer, you go to something called a sterilizer. So it sterilizes, it sterilizes.
I think maybe the one thing that maybe you can do as you're explaining, bring the mechanical side of things, so that at least someone who's going to be doing what you're going to be doing, or maybe because I remember you talked about you were doing juices and draws and all those stuff. Other companies maybe just bring maybe the technical side a bit,
okay.
in terms of, so that at least maybe someone knows, okay, as an engineer, what are you doing there? In pasteurizing, what are you looking at? Your machines, what are you looking at? So maybe you can just include that part here.
Yeah, not a problem. So Basically, on the processing side, right? If I would, if you were to be a mechanical engineer, I'll put it, which you would be a process engineer. They just use fancy words for the same thing most of the time. Yeah, there's just fancy words.
Yeah.
So that one thing, if you are in university, please make sure that you're really aware on your fluids of mechanics. Very important, because you need to understand liquid and the flow of liquid, which will therefore come with the characteristics of liquid. So now when you know about the densities, the Reynolds numbers, the viscosity, that plays a huge role on how, because handling a product is very crucial in the dairy industry.
Okay.
The way you handle products can have a very huge different outcome. So if you handle it rough, it will give you a different outcome. If you handle it soft, it will give you a different outcome. So now you need to understand liquid and flow of liquid, characteristics of liquid. How does liquid react in different forms, in different states? You need to understand pumps. So like I said, pumps, there are certain pumps that you use for certain liquids in certain temperatures.
Okay.
You get me? Certain temperatures. So for cream, you wouldn't use a centrifugal pump because a centrifugal pump is harsh. So you use it for your less viscous product. So like your juices, your liquid water. But in cream, you need to use a positive displacement pump because it's more gentle. It's not too harsh.
Positive displacement.
Yes, positive displacement pump or
Okay.
a lobe pump, they call it. Yeah, okay, if I go in.
No, yeah, go into it.
Maybe when you put on the video, you just put a picture there. You just put like a
more
picture
work
of a
for me.
different. Yeah. You just put a picture there of a different.
Sure,
So now, what that does, it treats product in different ways,
Yeah.
so that
Yeah.
you get your desired outcome.
Sure.
But then, like I said, understanding your fluid, I can use a centrifugal pump for a cream, but it has to be above a certain degrees. You get me? So now it means when I'm designing a pasteurizer, I need to make sure that if I'm putting a centrifugal pump, no matter what, when cream comes at this state, it has to be higher than this degrees. And I need to put instruments. That's where your electrical now comes in. I need to put measuring instruments to tell me that it is at that degrees. Because if it's not, I'm going to either make it harsh or it's gonna become solid. It solidifies in the pipe.
Sure.
And if it solidifies in the pipes, everything is gonna stack. And if it stacks, you're getting fired again, like I said. Because you need to now disassemble everything. The plant is down.
To fix it, yeah.
Customers don't want the plant to be down. Then it has to run 24. If they can make it run 24/7, it cannot stop. You get me? So now you need to make sure that you understand the process. So you need to understand your pumps. So understand your valves. So this is your hydraulics also, where now you understand different things. Your thermodynamics, that's your plate heat exchangers. Mostly it's done in chemical engineering.
And I think, which one is this one for HVAC, where you check the air pressures in different way for the aircon, the ducts.
Aircon, I think that's...
Is it thermodynamics?
It's thermodynamics also.
Okay,
but
sure.
Under the refrigeration side.
Refrigeration.
Yes, under the refrigeration side.
I would like to have a refrigeration sometime on the podcast.
Yeah, that okay.
Do you know some guys?
I don't who's doing, I don't know.
Because I know Lungile. I don't know if you remember Lungile.
Look, yeah, I think I think Thabo Sadiq is working in the refrigeration side. And there's this guy, he's working with the aircons, because when I was in the office, he came. We had an issue with the aircon, he came. And I was like, oh, you're working in this company. So yeah. So I'm not on the refrigeration side, so I don't know how that works. But I know on the plate heat exchanger side. Plate heat exchanger.
Okay, sure.
Heat exchanger. Okay, put it heat exchanger. So now if I say plate, I'm giving a category type of heat exchanger. So the heat exchangers just to change heat, And like I said, that also has its own understanding to say you need to use certain heat exchangers for certain jobs.
Sure.
And with certain number of plates, with certain number of characteristics. So if you're doing a mayonnaise, you use a different heat exchanger. If you're using a milk, you use different heat exchanger. Also depending on the value of... It gave me, they all play that huge role. And now the technology, that's what we come in as a company now.
Sure.
We develop better technologies
and
to hold
everything
everything better. Yeah, all those funny stuff.
Thanks.
But I think if you are in students, I would really recommend make sure that you, if you want to be in the industry that I'm in, which is the food and beverage, make sure that your fluid knowledge is it's up to standard. Your hydraulics knowledge is up to standard. Your design, very important. Your design has to be. We can teach you, to be honest, when you come to work, but it's always good. I was so ashamed of myself. I got there. And now they're speaking about valves. Oh my! I'm like, hey, I remember this thing, man.
I did.
Yeah, I'm like, I remember it somewhere, Hey, what's happening here? And they're there. They're expecting you to know. They get there. They're like, okay, now this thing has to be a Reynolds number of 65 plus. I'm like, hey, I remember Reynolds number. Hey, Vela was Reynolds number. Hey, what's laminar flow? What's turbulent? You get me? So if you take those things lightly, when you get to site, they expect you to know them.
Sure.
They will teach you the job, but they expect you to know
the basics,
basic stuff. To say once we're speaking about Reynolds numbers, your Reynolds number, laminar flow, the type of valves, you need to know them. You can't just be, if I'm speaking about a pump, you need to know. I didn't know that a tap is a valve, the type of a valve. I'm telling you, a tap is a type of a valve. And yet I was just using a tap, like, it's a tap, let's just open and close. But now I know, it's a type of a valve, it's a ball valve, you get me? So now that knowledge is the one that will make you stand out better if you are with maybe if they hire 3 or 4 of you at the same time, you become better than ever because you will have that knowledge and it puts you up on the straight path. But if you're doing chemicals, that's good because I work with the chemical engineers, most of the guys that did it. So it's more easy because they did the process designs a lot. So now they did your PNIDs and everything. We didn't do PNID, so I had to learn on the job when I'm there. But if you're doing electrical, I was speaking to the young men at church, and I was telling him to say, I think learn how to code. Not just also to code, but how to work with your PLCs, how to use controls of your PLCs, how to use, learn the different PLCs that are there, your Siemens, your Ellen Bradley, your Rockwell. Those are stuff that will help you. Learn how to use VSDs, those are huge in the industry that I'm in. So if you go there and you've got that knowledge, you are guaranteed to at least thrive. And you become a better person because we put you on, like I'm saying, if I have an automation issue with my pasteurizer, I call an automation guy. So he has to come and log in and see, okay, is everything, the sequence in the right position? If we're saying, let's do CIP, are this valve opening at the right time that they have to open? Are they closing? Okay, what's the issue? So if you don't have that knowledge, it becomes an issue. So that's why it's important. So if you can also read or learn how to do PNIDs, that will be best. They're quite universal, I noticed when I learned. So once you know the symbols, everything is the same. You go work in any company, anything should be the same. Even in the oil rig, I saw their PNID, I could at least 80% of their symbols I could recognize what they are speaking about. Then there will be those different ones which are specific to the industry. But majority of the symbols are the same. Should be just the same.
So getting back to the UHT.
UHT, perfect. So now we pasteurize our milk. We're all happy. 7 days or 2 weeks. Let's put it 2 weeks. We are happy, everybody.
To push it to 9
now
months.
I want to push it for months. You get me? So now we sterilize. So now when we sterilize, we take in the machine, we take in the milk, we're putting it into a sterilizer.
Okay.
So a sterilizer, basically what it does in basic form, it has something called a homogenizer.
Okay.
So a homogenizer is, you see the separation of your milk, remember in the beginning I told you the separation of the whey and the cream? So what the homogenizer does, it mixes that thing so much. So I don't have the spec of it. My manager won't be happy with me. But I forgot the spec. I'm not going to process it, so it's fine. That's processing stuff. But it basically mixes the milk and the fat,
the water,
the fat and the fat and the water, basically. The fat and the water, it mixes it so much so that it's not easy for it to separate. Basically, so it mixes it. So it is a very small opening, man, like very small opening, but it uses high pressure. Do 50 bars. It makes it 50 bars, so that's quite high.
Okay.
Very high,
Now,
yeah.
I wouldn't know what 50
You don't know
bars.
50 bar? 50 bar is like, okay, let's see. Your tap water is coming out at, your tap water is coming out like, your pressure should be like at least a bar. A bar and a half, or a half, less than.
Oh, is it the
pressure.
one? Is it the one for like when you're pumping inside the car?
Yes, when
The tires.
No. So when you pump the tire, what that tells you, it tells you the pressure within the tire to say, now there's this amount of pressure.
Sure.
So it means that pressure is the one that, I want 250 or whatever. So that's what you want.
Okay.
So something like that. But that one is in motion. So it actually uses pistons, like a car.
Okay.
It uses pistons. So I remember when I joined, my guy was like, actually, one of the thing we're using is actually more stronger than a GTI engine.
Okay.
That piston valve. So it's quite heavy duty machines.
Yeah, that sound.
Yeah, it's quite heavy machine. But anyways, so now it mixes it. Then after that, it heats. You heat up the thing. We normally use what we call tubular heat exchanger because they are more friendly to the product. Unlike plate heat exchanger, plate is like a plate. It's a stack of plates. Please put it there somewhere. Yeah.
I need to hire more people.
So it's a plate heat exchanger. You can put it somewhere here. So we use a tubular heat exchanger. It's like a tube. So basically, it's water. Milk flows inside. Then there's a covering on top. So that uses water. So we use water to heat up.
Sure.
So yeah, basically then. Oh, I didn't tell you what a heat exchanger is, right? Or how it works. Okay, anyways, if you need, you call me again. I'll come.
I think what I'll do maybe, just for the sake of the length of podcast, right?
Hey, how many minutes are we on?
We're on 40.
Thought we were on 15.
No, exactly. So what I'm thinking is, it feels like we can just maybe exhaust processing, then we'll get to the project engineering that you do after.
Yeah, what I do after.
Yes. So maybe let's just do the processing,
of
then maybe then we can just
definitely, because I think that's quite interesting. I think I want to become a salesperson and a project manager, so I want to leave all those processes. They're boring. So that would be nice. But I can also give an insight to saying what will maybe be one of my motives to do that. And because I think that's quite crucial when you go to the industry, to be honest. So, yeah, maybe we can touch on it next time. It helps also for people to understand when they go to the industry what to look out for. I think as engineers and as blacks, we normally just came because our parents said engineering is good.
That's true.
And it's got money, you get me. So when I got there, I noticed the guys who are doing the technical side, they're so passionate about it. And I'm there, I'm like, yeah, man, this thing is boring, man.
Okay.
Like, yeah, man, yeah. This thing wants me to know so many things for no reason. Like, hi, man. But for them, it's quite nice.
Sure.
But you notice that what I enjoy is speaking to customers. I enjoy showing customers how machines work. So now you notice that I'm in the right industry, but in the wrong position.
Department.
The wrong department.
Yes.
So I need to change my departments to go.
Sure.
Still do the same thing, but in a different department. But for me to move in that department, it's crucial to have the knowledge of the technical side.
Yes.
Because that plays a huge role. But anyways.
Who was I talking to?
We have to come to that one.
Okay, let's just continue. Yeah.
I have to come to that one. Yeah.
Yes.
So now you hit
the homogenizing. Because the thing is,
homogenize.
The thing is, most of the time when we look at the milk, these guys, they're actually right. You see pasteurized, you see homogenized.
Yes.
And for me, it's like, why are you confusing me? I just want milk. I can see your HD process, but I don't really understand what's happening.
Yes.
So
that's quite good. So basically what would happen, like I'm saying, so the homogenization basically reduces the quickness of the separation of fat and water in the milk, right?
Sure.
So even in your pasteurization, you can put a homogenizer.
Oh, okay.
And what that would also do, in a way, will kind of like prolong
the pasteurized milk.
The pasteurized milk.
But doesn't it also burn it like you were saying that?
No. Homogenizer doesn't. It uses you only do it like it's just pressure. Just pressure.
Makes
There's
sense.
no heat. There's no heat at all. It's just pressure. You just need to have your milk at 45 to 55 degrees so that at least it's warm. Must not be cold. It must be warm.
Sure.
Yes, that's all. But it doesn't introduce any heat. There's no heating in the homogenizer.
Makes sense.
Just pressure. Just pressure. Yeah.
It's
like I tell you, it's like trying to fit is what we call a bottleneck.
Okay.
In use terms, you've got this whole bottle and you've got this small thing, and
yeah.
you want to push the whole thing out at the same time. So what that does, if you put different mixtures in here and you press it, the outcome will be more mixed than when it's inside.
It makes sense. I think in terms of like high school science, it's like particles. When the
Yes.
particles are scattered and you want to put them into
together.
They have to like
Exactly. It's like also when you want to use clay, you do this.
Sure.
You squeeze them. So that's actually what it's doing.
Okay.
So it's
Okay, makes
actually
sense.
pressing them in together. So it's mixing them well.
Sure.
Yes. So
Sure.
that's what it does. So
Okay.
it does it in very thin, but in high pressure because it's already liquid. You get me? So with your naked eyes, you wouldn't see much because it's just
feels like
you just see white. You just see white. You don't see
Sure.
the difference. Like, oh,
Sure.
Yeah.
Sure.
So so now after your homogenization process, you go and you heat it up. You heat it up to 135 and you hold it for 3 seconds.
Okay.
Or just only 3 seconds.
And I'm hearing you saying holding. What does the holding process look like?
Oh, the holding process. So basically, holding process looks like it's a tube. So basically, I'm gonna give you a quick example. It's like basically you've got a pipe. You're gonna measure the length. You're gonna do your calculations and see that by the time this liquid moves from here to here, it will spend this much amount of time.
Sure.
So now, because it's moving quick, because you can get this may be something we can get to. You can get to different dairies does different volumes depending on how big you are and the big the market, right?
Sure.
So the biggest I've done on a one step was 40,000 liters per hour. This is quite huge.
Okay.
40,000 liters per hour. Then my colleague did 65, which is the biggest pasteurizer in Africa.
Okay.
Yeah.
Where is it?
It's in Woodlands, PE.
Okay.
Yeah, you must stop. Yeah, but that's the pasteurizer, not the sterilized. Yeah.
Sure.
So now, basically, it normally, if it's 30 seconds, it's like a spiral pipe. It's a spiral pipe like this.
Sure.
So now, what happens is, I'm gonna have an instrument here, automation again.
Sure.
I'm gonna have an instrument here that's gonna tell me to say, okay, cool. So I'm starting off the process. This thing, it checks, is it hot enough? So when I say I'm going to heat it to 93, it checks that is this temperature, is this product coming here at 93 degrees? So I'm going to use a temperature transmitter.
Sure.
Yes, it is at 93 degrees. This one at the end. So after I've done my maths, I will know that, okay, cool, I need to have a pipe which is worth 5 meters. So the liquid in there, by the time it comes from here and goes here, it would have held itself for 3 seconds
Yeah,
or
sure.
15 seconds, depending. Then I'm going to have another temperature transmitter there that will monitor to say,
Confirm.
is this temperature still the same as this one? So if this one notices that this temperature is less than 93, it's going to drop the machine. So it means that product is contaminated. We can't use it for pasteurization. So
I see. Okay.
it dumps this one, it closes the valve for the incoming product because now we have to throw everything on the ground. Because whatever is in there, it's no longer usable.
Sure.
So that's why I've said you need to be careful because it's a lot of milk. But the dairies, you notice that the milk in there is not that much. So they don't really mind, especially when you're doing commissioning, they don't mind that much because we need to check those parameters. We need to make sure that they are working fine. They are working fine.
Because I mean, the product, that, especially if it's going to be eaten by human beings.
By human beings, so now the regulations of standards they are quite high and everything. So basically that's what, when I say holding, that's what I mean. So there's gonna be a temperature that starts to say, okay, cool, is this at 135 degrees? Yes. Then after a certain number of pipes, I'm gonna have another one that will be checking, is this still 135 at the end? So if it's still 135, I'm happy, you can continue the process. But if this here says this is not 135, you would have a buffer, plus or minus. So probably you would have 135. So I'll probably put my set point. So set point is basically, this is the set point that I want, 135. But if it's 133, I'm just gonna give an example, and 136, it's fine. If it goes above 136, it's too high, it's too hot, it must drop, it's not gonna work. You don't want that. Now you're burning the milk.
Okay.
You don't want that. You're burning the milk. You get me? And now you're burning the flavor. That's when you now eat, you're going to feel that taste. This milk is like it's burnt. Yeah, exactly. Then on the other side, same thing. Is it still the same temperatures? Am I within range? If it's within range, we're happy. We go.
I'm now starting to think of design.
Yes.
So that's just process, right? And you guys are bring in the machines which are already designed already. Are you in the process of design? Are you included in the process of design, or you just go and implement everything in the process?
So this is what happens. If you go to hybrid now, they've got this mic, right? It's already working.
Sure,
Perfect.
sure.
There's no need of redesigning this mic if I'm going to sell it to Mr. Bonie, who wants the very same mic. But what they do, they give you the knowledge of understanding how this mic works.
Okay.
But the mic is not going to change. It's still the same.
Okay, makes sense.
You get me?
Yeah.
So now, when I go there, we've got a standard
Process.
pasteurizer.
Okay, sure.
A standard pasteurizer. This is how it works. But guess what? Mr. Bonie is a very sophisticated man. He says, you know what? I don't want this mic to have a high pitch of what and what and what. So we don't have to go and redesign a new mic. We use the same mic, but we just put new features inside. But when you put new features, you are also damaging the old ones and whatever. So now you have to be more careful in that. That's when now you also come in as Bonie in your processes to say, okay, cool, this is the standard pasteurizer, but I want it to have an homogenizer, I want it to have a deaerator, I want it to maybe have 2 strainers at this point, because I'm going to be doing Macheo. And Macheo, they clog their strainers most of the time. Strainers is like your filter when you drink tea.
Safe.
Yes, safe. Yeah, safe. Yeah, exactly. So I want 2 because your Macheo has more fibers, so it clogs the whole thing and it stops. So now, when they do that, we're not really designing a new wheel. We are modifying what we already have.
Okay.
But for me to modify what I already have, I need to understand how what I have works.
Okay, sure.
I need to understand the pasteurizer itself.
Do you have simulators?
Yes, we do have
simulate.
simulators. Yes, we do have simulators.
That simulate my hair.
But
That simulate.
No. But that's automation, not my side. I deal with PNIDs. I tell you to say, cool, when you're bringing in.
I think maybe explain what PNID is.
PNID is process instrumentation drawings. Yes, processing instrumentation drawings. So basically, PNID is, it shows you the whole picture,
Plant.
the whole picture of the machine, and it shows you all the different instruments in the machine, and it shows you the process of where does it start and where does it go to. So basically, it would show you how to. It's like a map.
It's plant layout.
Like a plant layout. There we go. It's like a plant layout. It shows you to. No. It's not a plant layout. A layout it shows you how the plant looks. But a PNID shows you instrumentations, designs, drawings of that machine. So basically, it shows you the valves. It shows you it shows you the tanks. It shows you the instruments that are there. It shows you the amount of temperature that it has to come in and comes out. If I had a picture, I'll show you. It's just quite. It's not that difficult once you get to know it, but when you're seeing it for the first time, it's quite scary. You get me? But it's just more of showing you to say, okay, cool. When I hold a PNID, I can easily look for, okay, no, cool. So now they tell me that we're getting a fault on the outlet temperature. So I can just basically go and see, okay, no, so which valve is that? So it tells me the name of the valve, the number of the valve.
Okay.
And it's easier for me to say, oh, okay, I think this valve might have an issue. Okay, cool. So if this valve might have an issue, what might have been one of the main problems? Okay, cool. I need to check this valve. So as a mechanical guy, I can only check the outside things. I can go check the valve itself. But that's why I said the automation guy, when the automation guy, he must understand the PNID. So that now when he does the simulation to try and see, oh, where's the fault? Okay, I think the fault is here. You get me?
Makes sense,
so that's basically what a PNID is. It's just it's a design that shows you instruments within that machine. It shows you the processes, how flow is going to be like, and what will happen. Because sometimes if I haven't reached temperature, if I'm washing the machine and I don't have to reach temperature, we do what we divert. So you need to first divert up until you reach spec. So you divert and go outside, go back up until you reach. So if I haven't reached 95 degrees that I'm looking for, the milk is gonna divert and go back.
Okay.
Divert up until I get that 95. Then you're gonna continue.
Which is a smart way of not wasting.
Yes, definitely. But you also don't want to divert for too long.
For too much,
Because you are now just reheating the milk again and again and again and again. Now you're gonna get that taste that we don't want. The bent on taste.
Makes sense.
Yes.
Okay. I think maybe let's close it on
Sterilizer.
I think we're finishing. You were finishing up on the
UHT. Yes, UHT.
UHT homogenizer and
So So now after homogenization, which is the process, after homogenization, you heat up 135 for 3 seconds. You hold it for 3 seconds.
Sure.
So you heat it up, then in the pipe for 3 seconds. Pandeka, that's the holding we're talking about.
The holding,
Not
yes.
holding it.
I mean, it's like,
Pandeka
okay,
is thinking
I'm
holding
like-
with his hand.
It's like it goes somewhere and it stops and it's being held.
No. No, it's in the same. It's in the same
Sure.
process, in the same machine, same
Yeah.
loop, but it has to be in that pipe for 3 seconds. So
Yeah.
it has to move for 3 seconds.
Okay.
Then it goes to the next phase. So now after holding for 3 seconds, you drop it down to your ambient temperature. You don't have to drop it to 4 because the pathogens, which is our number one enemy,
they're super
they are
sleeping.
dead. They are sleeping for a maximum of 14 months, but we normally put 9 months. So depending also on the homogenization, but 9 months is standard. So you can, depending if you can prove it, you can also go for 12 months or 11 months. Then the regulation will allow. But most of the time we put it 9 months on the sticker.
Sure.
It's quite interesting how there's a difference between expiry date and best before.
Now you can just educate
Quite
me.
okay. I don't know. It's something I also need to know because we use best before.
Okay,
but now
sure.
there's also expiry date.
Oh yeah. I think
So
maybe
best before basically means
it's the product.
it's no longer good,
Yes.
but
yes.
expired means expired.
Yes.
Yes.
I think it's pretty much straightforward as well.
But I think it also depends on the products you are putting.
Yeah, sure.
Anyway, that's a story for another day. Let's go. Fact check. Hey, where are you? Check the difference, man. Okay. Anyways, so I think after holding it for that, you drop it to ambient temperature. That's like a 25, 28.
Sure.
Room temperature. It has to be warm. Can't be cold. Because now the guys are sleeping, really are sleepy. They will not wake up anytime soon. Then from there, you put it in the easiest process to put it in. Now, this is more technical to say how you handle it. You put it in a aseptic tank. So aseptic tank. So after sterilization, right? After it's sterilized, your whole process must be aseptic. Aseptic means it must be closed process, closed loop. Nothing must come in contact with that product, including air. Not even a single bit of air must come in contact with that air, with that product. So if it does that, it's no longer aseptic. That's what now we say it has been compromised. We have failed sterility. So what is the crucial thing that makes that? Our wells have to be good. Our machines have to be up to standard in order for us to handle that.
Sure.
The process between the whole thing, the valves have to be aseptic. So now this is when we've got steam barriers and whatever to try to kill any air that way. So if we have an opening or something, which must happen because of the process, we always have what we call a steam barrier. Where steam is constantly blowing. So if there's any air that will come, it will die immediately. Nothing will pass through.
Okay. Sure.
So we sterilize it by steam. That's it. So now from there, you put in an 80 aseptic tank. So it's a tank, but it's an aseptic tank.
Aseptic tank.
Two different things. So that tank is aseptic. So it's clean. No air is gonna come in or anything. Then from there we pump it, take it to our machine, which is where I am now, which is the packaging. So now from a packaging, now it depends. You want to buy a Rolls Royce, you want to buy a Toyota, you want to buy. So where now it differs. You want to buy a machine that does 1 liter, half liter, 250 mil, 200,
Oh, so
different
because-
shapes.
okay,
different.
sure.
That's more now on the packaging machine. That's more of what the machine can do. Because you come, most of the guys might have not noticed it, but if you go the milk looks the same, but you notice the packs are different most of the time. So you can get like your square, you can get your slim,
Oh, yeah,
you can
I
get
see,
your
yeah, sure.
edge. Most of the time, this nowadays, to topic, we're going with the edge. It's like a pack with the edge shape that's like this.
Yes, I see it, yeah.
That's
Sure.
the new one. But our competitors, they steal from us, by the way, because we're the market leaders. That's what we're supposed to speak about, also about how when you, what they call it, patent.
Oh, paint. Yeah, sure.
Yes, basically, because we normally bring out this thing, but a patent, I think, lasts for like 15 to 20 years.
Okay.
Then after that, it has to be open to everyone. So that's what the Chinese are doing. We love you, Chinese, but you're bad people. So that's what the Chinese are doing.
taking
They'll
your
come
ideas,
and take
yeah,
our stuff and make it for cheap materials and whatever, and go sell it for less using our design.
already have
So
your
now what we have
technology,
to do, we always evolve, we always become better. We want to be the market leader, so we always change. We come with new machines that can do different shapes,
Sure.
that can do different things. That's why now we're also doing cartons, which is we're moving from tin stuff to try and put, maybe we can come back for that. That's quite interesting. I'm learning a lot there.
Sure.
Moving tin stuff into cartons. It looks brilliant.
Really?
Wonderful. It looks amazing when you hold the pack.
Yeah.
Your life will never be the same. You
So,
feel
so
like
tin, so it's like fish. It's no longer gonna be in a tin. It's gonna be in a cartoon.
we want to put it in a carton. Yes.
Nice.
We want to drop. I told you we're environmental friendly,
Environmental
man.
friendly, yeah.
Tin is not good for the environment. Man.
Exactly.
Save the air. So, like your beans, your cool beans.
Yeah.
Cool is just a brand, but your baked beans.
Yeah.
Exactly. Want to put that on a carton. It looks lovely. Trust me. When you
Nice.
hold it, you would feel like.
Now,
and it's more cleaner and more. It's actually cheaper. Number one, because the paper currently is way cheaper than the tin,
which makes sense.
price.
Yeah.
Also because of the war in Ukraine.
Ukraine, yeah.
And it looks more nicer, appealing to the eye. It's is safer to use
no longer heavy.
in your household. So normally you notice if you have tin, if you don't hold it well, you can even cut you or whatever. All those stuff. It's good, and we have proven that we preserve a better taste than tin. So
You guys are selling us.
sorry, it's good. Trust me. It's not dreams. Trust me.
But I think I trust you because, like you said, you guys
It's
are
good.
leading.
With the market leaders
Yeah,
in the
leaders,
in the food and beverage.
Sure.
So basically, what we bring, our motto is we protect what's good. So that's our number one status.
Sure.
So in car terms, when I got there, they told me, Bonnie, you are selling Rolls Royce. So don't think like you're gonna be selling Toyota. So when I go to the customer, I need to assure him I'm selling you Rolls Royce. You're gonna get Rolls Royce service. You're gonna get Rolls Royce performance. So that's it. Nothing less.
I like that. I really like that. But I think this conversation, I think what I'm getting out of it is for us to understand, which is one of the things. This was like my motto in the beginning. I used to say, Stege podcast, the workforce of the economy, and what you're explaining it because this is just an explanation on milk, but I think it also you can also translate it like you were saying mayonnaise, other stuff,
exactly,
like fish, yes,
exactly, because the process can, like I said, it's still the same, but it's just a little bit different.
Yes,
so like I told you now, when you're doing pasteurization, right? You need to now say, okay, cool, what do I want to get out of this? Do I want to get full cream, low fat, or fat free?
Sure.
My friend, fat free and low fat, my friend, no difference. Okay, but there is a difference for those guys who are clean.
Sure.
But it's, okay, I forgot those ratios because it depends from dairy to dairy, right? But fat free must be 0.05 maximum amount of fat in the milk. So it's not really fat free. Must be 0.05. So they will still have a bit of fat, but it's more. Then low fat, I think it's 1 to 1.5 percentage of fat in the milk. Then your full cream is 3. Can be more than 3.
Sure.
Yeah, if you do more than 3, it's no longer. They used to have semi, but they discontinued it, and so now it's no longer. Okay. Then from there, what you do now, you go to something what we call a separator. So what a separator does, it uses high speed, very dangerous machine. It uses high speed. It separates the water from the cream. Fat.
Sure.
So whenever I say cream, I mean fat, right? From the fat. Then after he has done that, it goes through, the fat will go through to something called a standardizer. So what it does, it basically calculates the cream that is needed for that particular recipe.
Sure.
So if you put a recipe on a do full cream, it's gonna take 3% of the cream and put it inside the whey, which is the water, and mix it. Then it becomes 3% and it goes. The excess cream has to go to cream cooler, which is like a heat exchanger again. Just a different name, fancy name. A cream cooler. It cools it down. Then depending now, this is something that we can come and talk about. Still Tetra Pak, we still do that. Now we move on to say we are going to do butter. That's now we go to butter churning, whatever.
Sure.
When you're done with that, sir, it's not done. You can even still take that. Now we go do cheese.
Come on.
It's a different thing that we also still do that.
So you still do that as well?
Yes, we do. We've got machines that do this. They
Sure.
go do cheese, and you can go do whatever cheese you want to do. If you're done with that, we can still come and say, now let's go do custard. It's a different process on its own. But it all comes, like it depends on where it's branching off from.
Sure.
But most of it branch from the pasteurized.
Sure.
That's where majority of it starts branching off. Then we're gonna go find what you do. Then you have to clean and everything. But the main one is the UHT milk that almost everyone has in their household, and Just what you want. So make sure that when you buy your packs, it might have a Tetra Pak logo on the side, or just look at the bottom. It will say Tetra Pak, and it will tell you the type of machine that was used to pack that.
So they actually write that.
Yeah, at the back you will see Tetra Pak TBA, Tetra Brick Aseptic. So that's the type of platform of a machine, Tetra Brick Aseptic. Then for people like us now, I can know, okay, is it an edge? Is it a slim? Even the caps, they actually are different, my man. Different, yeah, there's wing cap, there's light cap, and you'll be shown that it appeals differently to different markets in different countries.
Oh, I see.
Then you can have your TPH, Tetra Prisma. Prisma is what you normally do when you do they normally put your premium products, like your juice.
Okay.
Like your series juice, if you notice, like your rose juice, or those they put in the Tetra. But it depends. You can also put milk if you want to, but the pack is a little bit more expensive because it looks premium. So most people get to put those premium products in there.
Inside,
that's why you notice your juice is a little bit expensive, because also the pack is a little bit expensive.
And that means even the package.
The packaging, yes. So now that's what they normally do. But your milk, we normally use standard packaging. So because milk is a
daily,
it's a need, you know, in a way. So now we're trying to make it standard so that everybody can afford it.
Sure.
Yeah. Then the customer can put
I think I think I learned a lot, and thank you so much for bringing knowledge to those who are. I think it made us understand the thing that we use almost every day.
Definitely.
And I think even bringing the cheese, the butter side, it makes us understand.
It's quite interesting that most of the stuff we use in our
products,
daily day also. One catchy thing, I tell you this.
Sure.
Confidential, just because you listen to Steke podcast.
Sure.
All right. I won't mention names, right?
Yeah.
I'll just say random stuff, right? So after you sterilize, right, it goes to an aseptic tank. Remember, I told you.
Sure.
Then from an aseptic tank, it goes to the machines, right? That's where now they do the packaging. So household brands, Woolworth, Checkers, No Name, ShopRite, I don't know what they use. I haven't been there in a long time. Whatever they use, but household brand. Right brand.
Yes.
Household brand. Those guys, they do not have dairies.
Okay.
They don't have dairies at all. It's going to be expensive for Woolworth to go and create a dairy just for milk.
Yes.
They don't have the volumes to do that. So what they do, they go to the dairy industry. So I'm going to throw in an example. So Woolworth will go to
Clover.
Steakers.
Steakers. Yes.
And say, hey, when does we want you to put this milk for us in our own packaging as a household. Steak already has its own brand called Steakers Milk.
Yes.
Right? Now Steak is like, no problem, I can put it. Then they're gonna come and say, but you need to meet these regulations, right? You need to meet these regulations. Your factory has to be clean, whatever. Simple stuff, which is just appealing to the eyes most of the time. Sometimes they can be a little bit more into the process, but not too much.
Sure.
Then they're like, yeah, okay, cool. Then Steke and Mr. Woolworth, they have an agreement. You know what they do? The same milk which is sitting inside the AT, when it goes to the machine, once they're done with Mr. Steke's milk, they just remove the paper and they put Woolworth paper. Literally.
I think did you say the same thing about macaroni? That there's no difference in macaroni.
Macaroni, no, not really. Macaroni.
No, I think it was maybe a different conversation.
Exactly the same
product.
Same product. Just a different name.
Interesting.
Then they go put it up there. Then you're like, nah, me, I only drink Woolworth. My man. You're just paying for the name. The very same milk.
Sure.
Very same milk. No difference. Same milk.
Just because you listen to Steke podcast.
Just because you listen to
giving you this
podcast.
inside information.
Next time, if I come back next time, I'll actually tell you the right brands and the names so that you don't go and buy them.
I think maybe let's do a closing conversation here. So what have you learned the most in processing, which maybe helped, or which maybe helped you to your understanding of the work that you do?
I think on processing, one thing that it has really helped me is on a more personal, not just let's live career. It has opened my eyes in terms of what we eat, number one, where they are from. Most of the time I was just buying stuff, just eating without having to really learn about the processes behind it. So now basically it's quite interesting when I hold a can now, because I'm doing records. I always want to check, okay, who packed this? Okay, what did they use to do it? You get me?
Sure,
But before, and all those paper things, you think they're useless, and they're quite useful. You get me? For you to have a certain understanding. So now, being in that area, in this industry, has really put that insight in me to say, now I really want to understand what is it that I'm eating, especially if it's a category under the dairy and beverage.
Sure.
So basically, even your juices and whatever, that's how I would come and check. What is Revive? It's come from Revive, and I'll tell you that Revive is from Zim, because there's a company in Zim called Revive, which is Pro Dairy, which is the one that they pack, but they're packing milk, not this. You get me? So Revive was actually a company that was bought out by Pro Dairy, then they kept the name.
Okay,
so maybe that's might still be the one that has to do this, so I can go and do research now. You get me? So now I've got a little bit of that insight to say, oh, okay, cool, this is what we have. But besides that, it has just been, I think, a quite big transition from school to the industry, just trying to learn how industry works. I think that's also another topic we can talk about next time, probably. I come as a co-host. Please tell this guy I must be a co-host. Tell him.
We're gonna bring you as a co-host.
I think it's more of understanding self, understanding others, and basically self-growth. That's something that I feel was never part of me. I was not intentional about it or whatever. But since I've moved to the industry, I've seen things differently. Now I view the world in a different way. And I'm now no more scared to play with big numbers. Also, you get me? My first project was 5 million. I had never thought I would feel like I would work with the 5 million. You can get me?
Sure.
Now I'm literally quoting stuff that are like 89 million. And I have to be sure when I'm quoting it, because it's going to be on my head. And I have to take responsibility now. And I notice that it's no longer just me, but it affects the whole company. And if they're putting me in that space, I need to deliver. And I need to make sure that they can rely on me. Otherwise, I'm useless. They can remove me tomorrow. You get me? So that whole thing has really played a huge role in me to say, okay, no, now I understand the responsibility that comes with it. Now I understand why the big people who think a lot get big bucks, because it's the responsibility. The more responsibility you can, or the more decisions you make, the more money you're gonna get paid.
Management, you get a lot of money.
You get a lot of money because it's huge responsibility. In simple terms, the more responsibility you have, the more money you're gonna get. So it means the more important you are. Like the president, he doesn't do much, that guy. But he has a huge responsibility in it. That's why he gets big bucks and he gets all the supports he needs. You get me? Because it's important. So that being in the industry has just literally opened my eyes on that. Like I said, I don't think I'm really much a technical person. That's why I'm not even loving it. But in that, I still know what's happening. I know what's really going on. Now at least I know the basic stuff. So when I get home, I'll tell them, hey, you see, this now, is the type of brand that you're making me also reveal. So there's also something we do underfilling, which I didn't know. So basically, underfilling, not most guys do it, but just the guys, be careful when you go buy something. The standards is if you want to get more out of it. Okay, it's not a bad thing, but if you want to get more out of what you're buying, you need to check, mostly in the dairy industry, you need to check if it's in liters or in kilograms. So if it's in liters, if it says 1 liter, you notice that you're getting 1 liter. But if it says 1 kilogram, chances are you're getting less liters. Okay. Because especially in stuff like custard, and because what we do something what we call underfilling, and we put what we call headspace, nitrogen in our packaging. I didn't get much into packaging in our packaging machine. So if you put a custard is heavier than milk and whatever. So it's more denser. Sure. So they put 800, then they put nitrogen air, then it beefs it up, it says 1 kg, then they put 1 kg, but you're only probably getting like 920 liters. Sure. Not you must throw all this milliliters. Sure. So when you go to the shop, just be careful. Check, is it this in liters or in kilograms? If it's in kilograms, chances are they've underfilled. Don't buy it. Come on. Go to the competitor.
I love the knowledge that you have got and the secrets. And I think the second podcast listeners will be very excited about it. I think in closing, please advise someone out there who's listening to the podcast.
I'll say, go out there, man. I think these people need us, especially if you're black, man. I think we really have potential. The guys really need us. But when you get there, be aggressive, man. Something about myself when I entered, I was a bit shy, man, because I was the only black guy in the office, in the office, and I felt like it held me back a bit. But now I'm opening up. I'm like, oh man, these guys. It's not like they really know much, but the knowledge we have and the way we grew up as blacks, we've got a huge stamina and a huge aggressiveness to life, which most of them might not have. So I would say go out there and don't be scared. When you get there, go shine. Don't be scared of stepping on anyone's toes. Step on their toes and their legs and faces if you have to, but prove yourself that you can do it. I believe most of us, we can do it. We've got the capability. We just are too reserved as black people and we don't want to shine, you know. So I know the economy is saying that we've got high unemployment rate, but I believe if we can go out there and try doing something like when I came here, I was telling you on that very different business. Sure. Yeah, because I feel we can do it, man. Once you're in the industry, you notice that the money is broad. The opportunities are a lot inside. You get me? They are quite huge, and the fact that they're huge, we just need to tap in and try and do something, and we're gonna make it. To be honest, the opportunities are a lot. We just need to start doing something. Let's not sit down and relax. So if you don't have a job, or if you're finishing, please apply as much as you can. You will learn a lot if you go to normal corporate, but don't make it your lifeline. Please don't do your lifeline. That's very dangerous. You're going to end up in the rat race of the world. It's not good. But if you've been looking for a job for quite some time, trying to find something, please go out there and try something, man. Just go out there, try something. You've got the ability. And I believe the opportunities are quite big. You will grab something. Once you grab it, you're going to be the best in it.
Sure. I think maybe there's a lot of topics that we said we're going to catch up on.
There's a lot.
So
I hope you're writing it down.
No, I have a way.
Okay.
I'll tell you that. But I think maybe just since you've been sharing a lot of secrets, and maybe I can also share secrets. I use a lot of ChatGPT, so it actually reads out everything that we say. So I put a transcript, I put it there. What is it that we said we're going to write? Talk about it, and it tells me, okay, you said you're gonna talk about 1, 2, 1, 2, 3. Okay. Then it's gonna give me all that. So ChatGPT AI is also helping us as podcasters. Good. So yeah, I think there's a lot that we're gonna have to catch up on. But with that said, thank you so much for coming through.
No, it's good to be here, man.
It was really nice. I learned a lot.
Yeah, that's good.
And I was really impressed the time when you were actually he's a man of God, my friend.
Yeah,
he was preaching. So
we can prophesy numbers.
Come on now. Speak directly to the camera.
We can prophesy numbers. Hey, if you wanna get in contact with me, my numbers is 0. Okay, no.
On that note, let's wrap it up. Thank you.
Thank you so much, and thank you for Five.
Yes,
sponsoring us. I think that's quite cool. You already edited it. Okay, but it's quite good. I think it's good. While I was drinking this flavor, is good. Thank you so much. I appreciate it. Eh?
Awesome. Thank you so much for listening to this episode. I appreciate you taking time and tuning in and be part of our community. We get to share ideas, stories, and perspectives through this podcast. I hope you enjoyed it and found something valuable in it. Don't forget to subscribe and share with your family and friends. I look forward to connecting with you in the next episode. Until then, take care. This is Stega Podcast signing out. See you next time.